Hello and welcome back to Dataverse by NeenOpal. I am so pumped for today's session. This is episode number 17, and folks, we really need to have a talk about the state of AI.
That's a serious talk.
A serious talk, because if you think you know where this is all going just because you've, chatted with a bot or generated a few emails, you might want to sit down for this one.
It is great to be here. And honestly, you're right to set that tone. We are not talking about another incremental update.
No.
Or a slightly faster model or a bigger context window. This is a fundamental architectural shift we're discussing today.
We are diving deep into agentic AI, and I want to set the stage right away because I feel like agents is becoming one of those buzzwords that gets thrown around until it just loses all meaning.
Oh, absolutely.
Most of us right now, we use AI passively. I type a prompt, the AI types back, it waits for me, it's reactive.
Correct. That is the standard chatbot paradigm. It's a call and response system. You're the driver. The AI is the navigation. It doesn't turn the wheel unless you tell it to.
But agentic AI, that feels like we're taking the driver out of the seat entirely. We are moving from systems that just talk to systems that actually act.
Yes.
So let's unpack this. What is the actual definition here? Is this just a fancy way of saying automation scripts, or is there something, new under the hood?
There is absolutely something new here. If we look at the source material, the definition really hinges on this concept of agency.
Agency, okay.
In computer science terms, agency means acting with intent in a dynamic environment. So agentic AI refers to autonomous systems that can pursue defined objectives through self-directed reasoning.
Self-directed reasoning. That's the heavy lifter in that sentence right there.
It is. I mean, think about a standard automation script, maybe a Python script you wrote 5 years ago to scrape a website.
Right.
If that website changes its CSS layout, what happens to your script?
It breaks. Immediately, It crashes.
Exactly. It has no agency. It just follows a rigid track. Agentic AI, though, it operates with goal-oriented autonomy. It doesn't just execute instructions, it plans. It breaks a big goal down into steps.
Yeah.
It uses digital tools, and this is the key differentiator, it iterates based on feedback.
So if the front door is locked, it tries the window.
It tries the window. It doesn't just throw an error exception and quit.
The source material used this phrase that at first I thought it was just marketing fluff, but now I'm not so sure. It described them as autonomous digital workers.
It sounds like sci-fi, I know, but it's a surprisingly accurate analogy for the structure.
Okay, so let's make this concrete, because abstract definitions are fine, but I want to see this in action. Let's walk through that market research example from the deep dive material. This really made it click for me.
Good idea.
If I ask a standard LLM, like ChatGPT, to research competitor X, what happens?
It'll give you a summary of what it learned during its training, which, might be 6 months out of date.
Mm-hmm.
Or if it has web browsing, it reads a couple of top search results and synthesizes them for you.
Right. It's a sophisticated summary. But in an agentic system, let's trace the workflow. I give it this high-level goal. Do a deep dive market analysis on competitor X and schedule a meeting to present it. I press enter. Then what?
Then the agent takes over. And first, it doesn't just start searching. It creates a plan. It effectively says to itself, okay, to do this, I'm going to need recent pricing data, I need customer sentiment from forums, and I need their latest feature release notes.
So it generates its own to-do list.
A dynamic to-do list, yeah. Then it starts executing. It might autonomously search websites, and then it could spin up a web scraper tool to extract the pricing data.
And this is where the dynamic part comes in, right? Let's say the scraper fails because the competitor site has some, a pop-up.
A standard script dies right there. And agentic AI analyzes the error, realizes, oh, there's an overlay, and then switches to a browser automation tool like Selenium or Playwright, closes the pop-up, and retries the scrape.
That is the self-directed part. It's problem-solving in real time.
Precisely. And once it has the data, it structures it into tables, it analyzes trends, it generates an actual presentation file, a real PowerPoint or a PDF, and then because it has access to your tools, it hits your calendar API, finds a free slot, and sends the meeting invite with the deck attached.
That is wild. It's executing a whole multi-step plan without me prompting it between the scrape phase and the analyze phase.
Yeah.
It bridges the gap between I want this result and here is the work.
It turns you, the user, from a micromanager into a strategist. You set the what, and the agent figures out the how.
Okay, I'm sold on the concept, but I want to get under the hood.
Fine.
As an engineer, I know this isn't magic, it's architecture. The source describes this architecture of autonomy as a loop. It's not a straight line.
It's a closed-loop system. And we should break this down. because this architecture is what separates a toy from a real tool. It generally has 5 main components.
All right, let's walk through them logically. Component 1 is goal interpretation.
Right. So this is the input. The agent gets that high-level command. Generate a weekly marketing report. It uses natural language understanding, NLU, to figure out what you actually want.
The intent.
The intent. It has to map marketing report to specific metrics that you probably care about.
Okay, so it understands the mission. Then comes component 2, task decomposition. This seems critical. If you plan wrong, you're going to execute wrong.
This is the planning phase. And the source mentions techniques like REACT, which is reasoning plus acting, or tree of thought prompting.
Tree of thought.
Yeah, think of tree of thought as the AI brainstorming multiple paths before it chooses one. It's asking itself, should I pull data from the API first, or should I check the database? It evaluates the most efficient path before it even takes a single step.
So it's basically the AI talking to itself in a scratch pad before it commits.
Exactly right.
Then we get to component 3, tool selection and invocation. And this is where I think that whole chatbot comparison just dies completely. Because chatbots just talk. Agents have hands.
Digitally speaking, yes. The agent needs to pick the right tool for the job. And these tools are APIs, Python functions, SQL connections, browser environments.
And we're not just talking about public APIs, are we?
No, and that's a key distinction for our technical listeners.
Yeah.
We are often talking about authenticated environments. The agent needs to know how to handle API keys, how to format a JSON request for a specific endpoint, and how to parse the response.
Right.
The source highlights Microsoft Copilot interacting with the Microsoft Graph. That means it's touching your actual emails, your SharePoint files, or Amazon Bedrock agents, triggering AWS Lambda functions.
So it plans, it picks a tool, and it acts. But we touched on this earlier, things break. That brings us to component 4, which the source calls the critical step.
Yeah. Contextual feedback and replanning. This is the differentiator. I cannot stress this enough. In standard automation, if step B fails, step C never happens. In agentic AI, the output of the tool is fed back into the context window.
So if the API returns a 500 error, the AI actually sees that error.
It sees it, it understands it, and it replans.
Yeah.
It might say, okay, the API is down, let me try the backup endpoint, or maybe let me wait 5 seconds and retry. It essentially has a self-healing mechanism built right into the logic loop.
That is huge for reliability. But to keep track of all this, I tried this, it failed, and I tried that. It needs component 5, memory.
Yes.
And I want to get specific here because the source mentions vector databases versus key value stores. Why do we need both?
Great question. Think of it like human memory. You have your working memory, what you're thinking about right now, and then you have your long-term memory.
Oh.
Redis, or key value stores. That acts as the log or the short-term scratch pad. It keeps the immediate history of the current execution chain.
So that's the, what did I just do 5 seconds ago?
Right. But vector databases, tools like Pinecone, Weaviate, or Phase, they're the long-term memory. They store information as embeddings, which capture the semantic meaning, not just keywords. This lets the agent recall a rule you gave it 3 weeks ago, or a similar problem it solved last month, even if the phrasing is different.
So without that vector memory, the agent basically gets amnesia every time you close the session. With it, it learns and retains context over time.
Exactly. And that combination dynamic planning plus persistent semantic memory is what allows for these complex, multi-day workflows.
So we've got the architecture, it's robust, but who is actually building this stuff? Is this something I have to hack together on my laptop, or are the big giants selling this as a service?
It's both. And there's a bit of a philosophical split in the landscape right now between the enterprise, big tech approach and the open source ecosystem.
Let's start with the giants. I assume this is about safety and integration.
It is. You have Amazon with Bedrock agents. Their pitch is purely engineering focused. Deep integration with AWS Lambda. If you're a company with 1,000 serverless functions, Bedrock agents can turn those functions into tools for the LLM without you rewriting code.
And Microsoft.
Microsoft is playing the business context card. Their Azure AI Studio and Copilot stack are built on the Microsoft Graph. This is their moat. An agent built there doesn't just know facts, it knows your facts.
It knows who my boss is.
It knows who your boss is, what meeting you were in yesterday, and which Excel file you just updated.
Which is incredibly powerful, but wow, it also requires a massive amount of trust in their governance.
Precisely. And Google's Vertex AI Agent Builder is sort of in the middle, leaning heavily on their strengthened search and document parsing, RAD.
Okay, so that's the buy side of the equation, but I know a lot of our listeners prefer to build. The open source world moves faster. Who are the pioneers there?
You have to pay homage to AutoGPT and Baby AGI. When those dropped on GitHub, they were the spark. They were messy, sure, but they proved that the loop concept actually worked.
I remember that. People were terrified and excited all at once.
But now for production, we're looking at frameworks like LangChain. LangChain is sort of the glue code of the AI world. It's a modular approach that lets developers chain LLMs with specific tools. It gives you control. You aren't locked into Microsoft's ecosystem.
And there was one called Crew AI that sounded really fascinating to me because of how it structures the team.
Yes, Crew AI takes a different angle. Instead of one super agent trying to do everything, they push for multi-agent collaboration. You essentially build a digital org chart.
So I'd code a manager agent and a worker agent.
Exactly. You might have a researcher agent whose only job is to scrape data. It then passes that data to a writer agent who formats it. And a manager agent critiques the work and sends it back if it's not good enough.
That is literally recreating corporate structures in code.
It is. And it turns out, specialization works for AI, just like it worked for humans. Smaller, specialized agents often hallucinate less than one giant model trying to do it all.
That brings us to the so what then? We have the tech, we have the platforms. Why does this matter? The source talks about emergent behavior, which sounds both cool and slightly ominous.
It's mostly cool, but yes, it does require a new way of thinking. The big shift is long horizon planning. In software dev, an agent could debug code, write the test cases to verify the fix, and then push the update via Git.
But tell me about this emergent behavior. That was the aha moment in the reading for me. This idea that the agent does things we didn't explicitly ask for.
Right. Emergent behavior is what happens when the agent connects the dots in a way the human didn't anticipate, all to achieve the goal.
Can you walk us through the user onboarding example?
Sure. So imagine you task an agent with improved user onboarding conversion rates. You give it access to your analytics, your code base, your calendar. You don't tell it how to fix it. The agent might analyze the data and realize users are dropping off at a specific confusing screen. So it might independently decide to modify the copy on the UI, adjust some feature flags to change the flow, and this is the kicker schedule, a product walkthrough webinar. Because it noticed that users who watch videos convert higher.
Wait. So it inferred that a webinar was the solution.
It inferred that a webinar was a high probability tactic to achieve the goal of conversion, even though you never once mentioned webinars. It innovates within the bounds of its goal.
Okay, that is incredible, but I have to play the skeptic here. That also sounds terrifying. If I have an agent that can change my website, copy, and schedule meetings, what if it decides the best way to improve conversion is to give the product away for free?
Right.
Or what if it deletes a confusing feature that's actually critical for compliance?
That is the absolute right question to ask. And the source is very clear. This has risks.
Right.
We talk about hallucinations in chatbots where it just makes up a fact. But with agents, a hallucination isn't just a wrong answer. It's a wrong action.
Yeah, RMF is a very different kind of hallucination than writing a bad poem.
Exactly. Unaligned objectives are a huge risk. The classic paperclip maximizer problem, where an AI destroys the world to make more paperclips, is the extreme version. But in business, it could be an agent deleting a database table because it thought it was cleaning up clutter.
So how do we stop that? Is the answer just don't use it yet?
No, the solution is rigorous guardrails and sandboxing. You need human-in-the-loop checkpoints. An agent should never be able to push code to production without a human review.
And the source mentioned Dockerization.
Yes. You run these agents inside Docker containers. So if the agent goes rogue or tries to delete the file system, it only destroys its own little ephemeral box, not your actual server. Sandboxing is not optional with Agentic AI.
So for the listeners out there, the developers, the product managers who are itching to try this, how do they start? Do they need to buy an enterprise license?
Not at all. If you're a developer, the barrier is shockingly low. Start with LangChain or Crew AI. You need an LLM API key, OpenAI, Anthropic, whatever set of functions defined in Python, and a memory backend. You can build a prototype in an afternoon.
And for the non-coders, is there a drag and drop for this yet?
There is. Visual tools like Flowise AI let you build these chains visually. You drag a PDF reader block, connect it to a summarizer block, connect that to an email block. It's like building a flowchart that actually works. AgentOps.ai is another one mentioned for monitoring these agents.
So there's really no excuse not to experiment.
No excuse.
Yeah.
But the advice from the source is crucial. Start small. Do not try to replace your entire DevOps team tomorrow. Pick a low-risk, high-friction task like scheduling or data entry and build an agent for that.
Start small, but start.
Precisely, because this technology is compounding.
So to wrap this up, we're seeing a shift from smart tools to autonomous collaborators. We're bridging that gap between human intent, what I want, and machine execution, how it gets done.
It's a fundamental change in how we relate to software. We're moving from operating the machine to managing the machine.
And here's a thought I want to leave everyone with. It's a bit of a brain twister that the source touched on, the recursive loop. If these agents can update their own world state, reassess their goals, and change their plans, how does the definition of work change for us humans when the software starts deciding how to solve the problem, rather than just executing the solution we gave it?
That is the billion-dollar question. When the how becomes automated, the value of the human shifts entirely to the why. If you can't define the goal clearly, the agent can't help you.
Deep stuff. We will be watching this space very closely. That is all we have time for on this deep dive into Agentic AI. Thank you for listening to Dataverse by NeenOpal. Go build something cool, and please, for the love of data, keep it in a Docker container.
Yes, sandboxins. Thanks for listening.
See you next time.